Okay, let's start. So good morning, everyone, and thank you for joining this webinar. My name is Christian Nielsen. I'm a structural engineer working for Arab in Berlin. And unfortunately, Peter Debney is stuck in traffic. I believe he had a power outage at home, so he had to run to the office and didn't make it on time, unfortunately. But that gives me the pleasure to only say good things about myself. So that's great. I am I'm here to present some plugins that we've been working on based on the new Oasys structural API. If you don't know Oasys already, we have a suite of products, both structural, geotechnical, and also pedestrian simulation. And we'll mainly be focusing on the structural part today. We have been working on, or the Oasys team have been working on developing a new set of structural APIs, which are currently working for GSA and Aztec. And we'll be showing you some of the things we've been working on to make that easier to use in today's webinar. So the soon to be released Oasys structural API is it's an .NET application, which is means that you can write code to interact directly with tools like GSA and Aztec. The API is based on .NET, and it means that you can write code with C# and VB.NET, and it also comes with Python support. And really, this is allowing more engineers to get started with scripting and automating their workflows using these new APIs. And because not all engineers perhaps got a good coding background or are fluent in C# or VB, then we have decided to develop some custom plugins for selected platforms. So we are intending to support Speckle fully, and we are also developing these custom plugins for Grasshopper, which I've been developing over the last year or so, and we're looking forward to showing you this here today. So why Grasshopper? Grasshopper is all about creating logic around geometry, and if you want to do optimization, geometry is the best place to start. It's at the core of what we do as engineers, as structural engineers at least. And whether it's optimizing support points, as you can see on the little image video here, or whether it's optimizing the rebar layout, it's all about geometry. And then Grasshopper is also a low-level entry to getting started with coding. So as you can see on the right-hand side of the screen, it's Grasshopper is based on nodes that you connect with wires, and you build up your geometric logic that way. So it's really easy to get started with, and being able to do advanced stuff, FE analysis inside Grasshopper is to us a huge potential. So why do we need a GSA and Aztec plugin for Grasshopper? Well, firstly, it's the first time we believe that a full suite of analysis and design for structural engineering is being wrapped completely inside Grasshopper. So that means that you got really advanced solvers, and some of the best FE solvers that are out there are inside GSA, and we are exposing them through this plugin. You got quadratic meshing, so that's quad 8 and tri 6 elements, which are much more accurate than triangular meshes for analysis. And then finally, we are exposing some of the nice features of GSA, which is the remeshing tools you can see here on the movie, also the video clip, that we are remeshing 3D elements, 3D members, and we are exposing all of this inside Grasshopper. Rhino does have some really good functionality for creating quad mesh, but they're unfortunately not always suited for finite element analysis. Then another key selling point is we're not talking about interoperability anymore. GSA and Aztec, they will be running headless inside of Grasshopper, so they're running on the same thread, and you don't have to export or import models. It's all living inside of Grasshopper. And then I think that an issue I've had previously in the past is that you can create only the early stage models in Grasshopper. You can't really take it further than the early stage. But with the new GSA and Aztec Grasshopper plugins, you'll be able to work on all stages of your project. You can create a parametric model from scratch. You can open an existing model and edit that, and you can start automating the documentation of results. It's really up to you. You can save your model and you can have your peers review it. There's no black box anymore. It works seamlessly with existing GSA files. So maybe we start digging in a little bit deeper into the GSA plugin. So one of the things we try to do with the plugin is to make it as easy as possible to work with existing geometry. So we created these new so-called Grasshopper parameters, which are based on Grasshopper geometry. And then we map that to the GSA objects. So yeah, if you start from the top here, in GSA, we speak about nodes, and that would just seamlessly be a point in Grasshopper. An element, which is the analysis element in the analysis layer in GSA, would be a line. And there's complete interoperability between these two, so you can just convert on the fly from a line to an element or from an element to a line. Yeah, and you can see the rest here. Element 2D is a mesh. Element 3D, they're a bit more difficult, so they're n-gon meshes, but you can still work with them in Grasshopper. And then we have finally the members, which are in the design layer of GSA, and we have some custom conversion routines in the back that helps you work with NURBS geometry easily. So maybe we just have a quick look at how these conversions work. So we open an existing model that contains some geometry. We also have the G there is a model parameter, so you can also pass around models inside Grasshopper and you can combine them. So here I'm taking out the element 1Ds. They are just converting straight into lines. You can select them so you can see which ones it is. You can actually move them as well. You can yeah, here you can convert all the nodes directly into points, so you can see. The model also contains 2D elements, so can convert that directly into a mesh. I can convert the members directly into surfaces, the member 2Ds into surfaces, and finally the member 1Ds, I can turn those into curves. Yeah, so you can see how that works there. In terms of speed, I believe we're doing reasonably well. A model with 150,000 nodes and 40,000 elements creates the geometry from memory in 6.8 seconds. And just opening the model in memory took 11 seconds, as you can see on the timer there. GSA got these two layers, analysis and design layer. And with the design layer, it's really easy to create FE geometry. So you can see that I'm just creating one line in the analysis layer, and then I can turn that into, in the design layer, and then I can turn that easily into an element in the analysis layer. So you don't have to think about intersection points, splitting your curves, splitting your members anymore. You just create stuff, continuous beams, and then let GSA handle the intersection and the noding out for you. So all that is also exposed inside Grasshopper. We can take that a bit further. So this is an example with 2 walls. First, I'm just playing around with the mesh density. So it's remeshing live inside Grasshopper and Rhino, and I want to find the intersection points here with a curve that I'm drawing. And you can see that the mesh is automatically adjusting and inserting nodes in the intersection points, and I can move this intersecting line around, and the mesh updates automatically. I'm not sure how well this example shows on your screens. Perhaps it's a little bit small, but you can, yeah, as you saw, you can mesh surfaces live inside Rhino viewport. You can just drag the nodes around, and it will automatically create a very nice FE mesh. You can also draw a second surface here and just rotate it 90 degrees, and then have a look at the intersection between the two. You can see there, if you zoom in, that it's a really nice FE mesh that nodes out, gives you a nice proportion of your faces. Then lastly, we also have the 3D members, which here is just playing around with a parametric arch. And yeah, I can drag that around, and you can see that it's creating brick elements on the fly, which is then, yeah, exposed inside the plugin. Finally, we also implemented some custom tools. So if you have NURBS curves or NURBS surfaces, so that's non-planar stuff, we can create we can create the mesh, the analysis mesh directly with the plugin. So here, this creates tri-6 elements and quad-8 panels. Yeah. So there's a little bit of an intro of the features. Perhaps we can talk a little bit now about how the plugin is intended to work. So on the top here, you see we are under the GSA tab in the Grasshopper ribbon, and on the model, if we start from the left to the right, on the model you have some tools to open a GSA model, save a GSA model, get the geometry, get the section properties, get things that are in an existing model. Under properties, you have ability to create sections. That's for 1D elements. You have properties for 2D elements. You can create things like offsets and springs and hinges. Boolean 6 is a hinge, or a fixation for a support point. Under geometry, you have everything that has to do with the model geometry. So that's nodes, all the elements, and all the members. You can create from scratch, or you can edit. So you can edit the property, or you can edit the nodes, you can edit the mesh size and things like that. On the loads, you have all the typical loads. So you have gravity and beam load and phase loads. So you can create panel loads really easily on surfaces. And you also have the so-called grid plane surface loads, which are loads that automatically expand onto the elements that you've selected. Then that all comes together in the analysis component, where we assemble and analyze. You don't have to analyze if you don't have any tasks in your model, but then it just assembles the model for you. And then finally, we can look at the results, where we have node results, 1D, 2D, and 3D results, which are not shown there, but we also have 3D results. I don't know if you're all familiar with GSA, but typically in GSA, you would be talking about an element, and then you would have to directly describe in GSA what property number that element has. So in this case here, we are creating a new element 1D from a line, and we're giving it a property PB42. So this would be the typical way that you would work in GSA, and then somewhere else in GSA, you would then define what that PB42 is. And in this case, I'm just giving it a standard I section. That all come together in the analysis component. So that's one way of working, where you simply just define which property number your element ID, your element has. Another way of working with the plugin is that you attach that property to the element. So once you combine that in this component here, it now knows downstream here that it actually contains this property 42 from before. Yeah, that's just a little bit about how to work with the plugin. Maybe we can move on to some of the more sexy stuff with the nice colors, analysis results. So first example I have here is just a 4-point surface, and I want to look at the node results first. So here we can look at reaction forces first of all. We can switch that over to nodal displacements, and we can scale the nodal displacements. This example here is from 2D elements only, and on the 2D elements we can look at displacement, we can look at forces and moments. There was no actual forces in there, so we just have moments in this case. And then stress, we don't have anything in the middle layer, so we have to go to the bottom layer, and we can look at the different stresses in the different directions. And then, yeah, switch it back to displacement. One thing that we have started to implement is a thing called a unit number. A unit number is very useful when you want to work in, say, Rhino meters, but you want to define your cross sections in millimeters. So a unit number is simply a value with a measure, and become even more useful when you start to work with forces. So here I can say that I have a force, it's 150, and the measure is Newton. And this converts on the fly to a number parameter, so I can get the number out, and I can also get displayed what unit I'm in. I also have another component which converts it into the selected other unit. Of course, of the same unit, I can't convert length to force, but I can convert force to another type of force. So here now I'm going from Newton, or let's change that to meganewton, into kilonewton, and yeah, that should hopefully make it really easy to work with different types of units from around the world, whatever you want to work in. So we switched over to the Aztec plugin now that we have the results from our little test. So we want to check the internal forces against a cross section. So we're exposing these unit numbers inside every component where it makes sense. So if you want to create a rectangle here, you can decide in the component what unit you want to be using. So you don't have to input the unit number, you can also just input a number. This takes both inputs. Then we have the catalog sections down in the bottom, where I just looked up a UC profile from the huge catalog section that comes with Aztec and GSA. I can also specify a material here. We also have most codes in the world covered, so we have all the parameters for each material hard-coded into Aztec, which we can look up. So now I'm creating a concrete section here to UK National Annex C40, C30, create a steel section, and then I can combine those two into a composite section. Yeah, that. Then maybe we want to create some reinforcement. So reinforcement is of course also parametric. So here change the top layer position and the diameter. You can change the bottom diameter here, and then we can also define using some of the built-in parametric tools in Aztec. So Aztec knows things about the code that we're working to, so bending radius, allowed bending radius, and spacing in between bars and stuff like that. So there's some parametric tools already that takes care of that for you. So we can use that as well. And then when we've done that, we're ready to analyze the section. So I'm taking out the profile for now. So this is just a simply reinforced column. And I can get the failure surface out. So this is a 3D NM diagram. I can then plug that into my ULS check component, where I can input a load. And you can see that the component turns orange, gives you a warning if you're outside the utilization, and it is nice gray if you're inside, if your load is not failing. And then if we are if you're not happy with the capacity, you can then insert the profile from before to make it a composite section. And you can see here the failure surface expanded. You can see it's got this nice cigar-shaped thing, and you can apply pre-stress, and you can apply anything you want to this really. That was more or less the end of this. So thank you very much for tuning in. The GSA plugin is currently available on Rhino's package manager, and you can install it through there. You need to have GSA installed, but if you do have a GSA installed, it's free to use. Aztec plugin is currently in early alpha version being tested internally, and hopefully we can release that later this month. Right. So, any questions?
Thank you, Christian. That's great. Yes. So,
hey, Peter.
I know I'm here at last. Sorry, power cut and nightmare as you're traveling. Anyway, yes, I'm here. So yes, if anyone has any questions, do please put your hand up. I think we've got a couple of questions already in the chats. So you can put hands up or put the question in the chat. So one's already come in, Christian. Is this on Food for Rhino yet?
It's not. It's as I said on package manager. So you can just type in package manager in Rhino. I don't know if you can read that up there. In Rhino 6, I believe the command is test package manager written out in one long go, and you don't get the auto completion in Rhino 6, but in Rhino 7, it's just package manager, and you just search for GSA and you hit the install button.
Okay, wonderful. Right, I've got a question from sorry, Catherine. Let me unmute you, Catherine. Catherine, can you talk? Did that work?
Yes, sorry. I was struggling to get the microphone working. Yes, I had a question regarding the way it works with 3D curves and trusses. What happens if you have a sphere, for example, so an enclosed surface? Does that work as well? And yeah, thanks.
Right now, the way it works is to use Rhino to unfold the curved surface and then do the meshing, and then you can't see my hands. Unfold the surface, do the remeshing, and then map it back to the same UV space. And that currently just works for not extremely curved surfaces. So a sphere is probably not going to work. But you can create your own mesh, and you can just create it directly from in analysis layer if you want.
Great. Okay.
So yeah, you can. Yeah, you don't have to use all the tools that we provide. You can just create your own mesh directly, edit it as you like.
I see.
All right.
Yep. Thank you.
Okay, thank you. Right, Dan Cole. Let me microphone on. Dan, do you want to ask a question? Dan, are you there? Did I unmute you? I unmuted you.
Sorry, I had to unmute myself.
Okay.
Yeah, thanks for the talk. It looks really interesting. I just wanted to know, in terms of licensing for would you need an Aztec license for the Aztec components of the plugin to work, or just within the GSA license?
I'm not sure how the Aztec plugin works right now, Peter, but I can speak about the GSA one.
So the Aztec API does require an Aztec API license, and it's the current plan is that they will be supplied with 100% discount with Aztec licenses, at least to begin with.
Yeah, great, thanks. And could I also ask, do you know when you expect to release the full version and get it out of beta?
I think we aim to do that before Christmas, but I can't make any promises on the On the GSA side of things, the Aztec
Yeah.
side, I have a bit more control over, and that we will definitely get out before Christmas in full release.
Great.
It's pretty much there. There's
Cool,
also
thanks very much.
less complexity involved in Aztec.
Okay, thank you. James Solly, do you want to unmute yourself and ask your question?
Hi, Peter and Christian. Thanks for the presentation. It's quite exciting to see this sort of finally happening. I think it's been something we've all been looking for a while. So it's looking amazing from the first view. I think my first question, which I'm not sure if Christian just answered, was you mentioned partway through that the API itself was soon to be released or something along those lines. So in terms of accessing the API from, for example, C# and our own code, is that something that we can expect soon, or are we going to be just able to access via the Grasshopper plugins for now?
No, the Grasshopper plugin will ship with the DLLs that's required for the API. So you will be able to access that through code.
Okay.
Currently, there's a beta version out of the GSA API, which has been out for a couple of years, and it's kind of a test. And we're working, the Oasys team is working hard to make that a fully covering all aspects of GSA. There's a lot of aspects to cover. The Aztec API has been released here a couple of months ago, so that's already out. Believe you can get your hands on it if you have an Aztec license. Otherwise, yeah, just get in touch. It's not we're not hiding anything. It's cool. We can get it out to you, and that's that's just, you can interact with that. It comes as a NuGet package, so I actually think you can download it from NuGet now if you wanted to. I'm just not sure how the license would work.
Sure. So at the moment, it will work with our GSA license, though.
For the GSA, you would have to have GSA installed. It literally looks for the GSA API in the installation folder.
Okay, fine.
You can install the plugin, it just won't do much without it.
Yeah. No, thankfully we do have GSA. Cool. Thanks, guys.
Okay. I think we got let me unmute Sally. Sally Albari. Yeah. Sorry, that's not pronunciation.
Hello.
Hello.
Yeah, can you hear me?
Yes, we can hear you, Sally.
Hello, can you hear me?
Yes, we can hear you.
Yeah. Hello, I'm Saleh Al-Bahiri. Actually, thanks a lot for this amazing introduction for this component. Actually, my first question was regarding the programming or using Python, for example, with this tool as well. So I would like to know about this more. And also my second part, or the second part of my question is, I'm doing now my master thesis, for example, and I'm quite curious about the structure analysis in general for my model. And so I was wondering if I could show some criteria or some structural criteria for my model, like stresses, buckling, or utilization in some way through GSA. Thanks.
Yes, so the API, at least the one that we released for Aztec, comes with some examples for how to write Python code. So there's a documentation for that. With the GSA plugin, you can use the Python components inside Grasshopper to create your own code. And you can interact with the plugin, and you can use the functions that the plugin is making use of internally. So all that is exposed. Currently, you can't. There's some limitations to what you can get out in terms of results. You can see stresses. You can't see. You can see stresses. You can see buckling behavior. but you can't see load combinations and you can't see user modules. So you can't see, for instance, steel utilization. Yeah, there's nothing stopping you from just creating a task that has the combination in it. And there's also a method to do that inside GSA, I believe, to convert your cases into tasks. And yeah, you can write your own checker, of course, but I know that's not ideal. Did that answer all the points?
Yes, sir. Especially the second part, it was like this. But like, if you would allow for me, like, I just want to discuss some idea, or maybe I would think it would be useful more if there is some tool inside the GSA, for example, for evaluating, for doing some evaluation for the structure in the Grasshopper. Because while we are working with the Grasshopper and we're getting our structural options through the parametric design, we can find many options. So wouldn't you think that it would be better if there is something could help us to evaluate these options and pick the best one? Or what do you think? I'm also so curious to hear your opinion.
Yeah, I think that's one of the main reasons why we're exposing this in Grasshopper, because we don't want it to just be a black box where we give you all the results and you just press a button and then out comes the building. We as structural engineers need to be able to interrogate the results along the way. And we're not like the automotive industry. We can't just create workflows that just solves everything. It's why it's fun to be in this industry, because every project is unique, and we can't really automate our workflows truly from start to the end unless you do the same project over and over and over. So that's why I believe that Grasshopper is a great tool, because it's the closest, at least I've found, that we can get to something where you can sort of automate geometry. You can create your own logic in there, and then we're just providing the tools to do the analysis as well, as close as possible to the core of where the value is really happening, and the value is really your engineering thoughts. And we're just providing the tools to make that easier. So I don't think that we can create something that would just tell you which one is the right solution. I think you have to do that yourself.
Thanks, sir.
Okay, Christian, I've got some questions in the chat. So there is a Cisco, sorry, the text is a bit small. How do you input seismic and wind loads?
So seismic loads you can't right now. You can't set dynamic results, and that will be covered in the final release, of course. But wind loads you can, it's just you can use grid surfaces, and we've seen some examples inside Arab of how that can be used. So it's mapped to Eurocode, where you have your different pressure zones, and it's pretty straightforward with grid plane loading actually to create something that simulate the Eurocode. I'm not so familiar with wind codes outside of Europe, but I'm sure similar would be possible. So that's with grid plane loading.
Okay, thank you. So question, maybe, does GSA and Aztec cover timber structure and Eurocode 5? Maybe I should take that one. So Aztec is concrete composite set structures, so that doesn't cover timber at the moment. You could possibly adjust it to model timber, but we don't have timber materials in Aztec. GSA, you can model to timber structures. Doesn't have Eurocode 5 in there at present, but timber is something we're looking to expand very shortly in GSA, and there'll be more news on that shortly. But we can't say too much at the size moment. So yes, you can model timber, and there is more to come there. Okay, question from Chumantang. Is Aztec plugin with crack width designed? So can you access the crack widths in Aztec via the API yet?
Yes. Yes, you can, and they are to code. So they will be displayed at the right location, whether your code defines that as a crack width to near the rebar, or if that's a crack width at the edge of the profile of the main section. So all that good stuff is built in, and Aztec knows about which code you're working to. You select that, and all the requirements are in there, and that's exposed to the API, and that's accessible with the plugin.
Excellent. Of course, every code treats crackings differently, and Aztec deals with all those individually. Okay, question from User Wang. Can you update the data in the existing model, like in adding and deleting elements in the model?
Yes. So that's one of the things that are really powerful, is that you can have an old model maybe from a couple of years ago, and then you can go in and you can try with different profiles. If you want to update that, you can use, as I said, actually all the transformation components inside Grasshopper. So like the move or the mirror or rotate, you can use all of this to create. So you can just create one floor, and then you can open this in Grasshopper, and then you can copy it up to however many levels you want. So you can build your tower easily like that. Yeah, you can change all the properties in there, and you can merge models. You can copy loading from one model to another. Yeah, it's really flexible to work with existing models.
Excellent. Right, where were we? Will the Grasshopper plugin be updated with new GSA versions? Tom?
Yes, it will.
Are there tutorials yet?
I don't think there are any available. That will definitely also be part of the official release when we get to that. But yeah, you are more than welcome to contact me if you have any questions. And yeah.
Okay. So some question from Hermit. It's about optimization of trusses. We want to do work target, minimum work, maximal least force path. And can Aztec do work done? Force times length. Actually, we'll say Aztec doesn't know about the cross section, element length, but GSA does. So Herman, I think if you're looking at doing optimization of trusses with Maxwell's low path theorem, you were looking at GSA rather than Aztec. Aztec, you can do the detail of the cross section. GSA, you can look at the structure as a whole, and I'm sure you can write your own Grasshopper components for doing your Maxwell's low path if they're not already available.
And you can use GSA to look at the strain density, which is a really good optimization criterion.
Question: will we again about tutorials? Will there be video tutorials?
It would be like Khan Academy, but for structural engineers in Grasshopper. It will cover everything. Maybe I'm making too many promises now, but yeah, hopefully it will be a bunch of video tutorials where you can just pick up where you want to, and it will suit your level. And yeah, we will cover all the dark corners of the plugin and of GSA as well.
Excellent. A question from Alfred: will there be a recording of this presentation available? And I can see yes, it is being recorded and will be uploaded onto the Oasys YouTube and Vimeo channels shortly. What we've got? Satyan, is the module supported by the design codes and shows the effects on design output as part of parametric studies? Cause what I understand is the structural optimization ultimately about the final effects and design. Okay, not quite sure what it means. Satyan, if you can clarify your question, I'm not quite sure what that is, but I'll come back to this. Question of from Daniel, can we link this into other design programs and BIM software?
So yeah, I mean, the idea is of course not to create a GSA plugin that supports ETABS. That was never the intention, but I would like this to support Speckle fully, so that we can convert on the fly to Speckle, and we're just waiting for the Speckle version 2 structural schema to be completely in place, and then we're gonna support that. And that means that when ETABS got a Speckle plugin, that you can then create your geometry with the GSA plugin and your model, not only your geometry, but your entire model, with cross sections and load and the geometry, and then you can stream it via Speckle and download it in ETABS. Perhaps there's also, you're also asking about the BIM software. So one cool thing we found is that it does work with Revit inside. So you can run the plugin inside Revit, for instance, where we have some use cases in Arrow where we've been looking at showing column forces using this plugin with Revit inside Rhino inside Revit. There's a lot of R's in that. Rhino inside Revit, and yeah, so you can start documenting the forces inside of Revit using the plugin.
Thank you. Question from Mohammed. Can this plugin support dynamic analysis? And if it can, will it include the animation?
Currently, you can display the dynamic results, and you can use the slider to change the shape. So yeah, I'm not really sure if you can if we can make something that can create a video, but I think you can do that manually with the normal animate. How is it? You right click on one of the sliders and then click animate, and then you can create a video from that. So that's possible already.
So question from Cisco, you showed a high-rise structure. How much RAM does your computer have, and how much RAM would you recommend for a large structure?
I'm not really sure how much my computer got actually. It's not. It's still just. It's not like CFD analysis or anything like this. It's still just, I think, a normal, decent computer that can run Rhino and Revit, will be more than fine to run this.
Yeah, certainly. Yeah, the bigger the structure, the more RAM. But there's not a sort of direct relationship. A little bit depends on what type of analysis you're running and so on. So, yeah. Right. The GSA plugin shows design outputs like reinforcement requirements, crack widths, and utilization ratios or stress ratios, etc. Okay, so GSA can do the steel member design and show utilizations and so on, and then for the reinforcements and crack widths and utilization ratios on concrete side, use the Aztec plugin, and with the two APIs, they're going to be much more closely coupled in future. But yeah, still with GSA concrete with Aztec at present. Do I see another hand raised from Robert? Robert, let me allow your microphone. Robert, do you want to ask your question? Might need to unmute yourself.
Yeah. Can you hear me? Yeah.
Yes, we can hear you, Robert.
Yeah. Thanks for the presentation. I'm just going to ask about, obviously, for Rhino, you're visualizing the results and stuff through Rhino's sort of whatever their function, your geometry is to show like the results, the contours and everything. If you're doing sort of like a bigger model that might have longer analysis and you want to sort of compare them, you just like sort of bake each different option out and then compare them at speed instead of waiting for the analysis each time around, say if you're like swapping between different parameters.
Yeah, you can have different models open at the same time also, so you can just toggle the view on and off if you want that. Or yeah, you can bake them into different layers and have a look at them separately in peace, so to say. You can save your Rhino model with the.
Did you say
method.
View the loads as well in Rhino, or was that something that wasn't?
You can't currently view loads, but that's in the pipeline.
And I suppose there's no bridge loading, like sort of the bridge loading from within GSA. You can't use it yet. You'd have to like sort of figure out the loads yourself and apply them externally.
Yeah, that's another thing that's not covered yet. The bridge modules.
Thank you.
Right, thank you. Is there any? No more hands are up. No more questions in the chat. I think that covers everything. Right. Okay. Thank you very much, Christian. That was excellent. And we're looking forward to seeing seeing more of this very soon. This is an excellent preview, and so you can always already download it as it stands, and yeah, ongoing development will be happening over, well, I'm sure many years to come. So thank you everyone for attending, and this recording will be online shortly, and we look forward to seeing what you yourselves do with Christian's work. So thank you very much.